Assalamu alaikum and welcome to our project StreamInsight IoT, IoT Data Simulation and Analytics. Here is an overview of what we'll be discussing. This is the pipeline we will be following. It's a classic. We first collect data from our sources, then ingest it, process it, and store it, so we can serve it and analyze it. Of course, an orchestrator ensures everything happens as intended. In our project, we faced many challenges and gave a solution to each one. For generating data, the challenge was to simulate many devices. We chose a programming language. To handle load, we ensured that no data was lost and information propagates swiftly. For the collected data, we selected an adequate database. And to meaningfully display it, we used a web interface. For the chosen technologies, we used Python for generating data. To handle load, we made use of Kafka and Spark. To store data, InfluxDB. And Grafana was the web interface we've chosen. Finally, Docker Compose was the orchestrator. The final architecture becomes the following. Each of these is a Docker container. Here is an example dashboard you can make with this project. Thank you for your time and mentorship. I'll now give the stage to my comrade to demo everything.
Assalamu alaikum. Today I'll be discussing our cloud computing big data project. It deals with collecting and analyzing information from IoT devices in a big data context scalably and robustly. This is an overview of what we'll be discussing. We first talk about the architectural choices that we have made and the technologies that we've used, and then we live demo it. So we followed a pretty standard big data architecture in this solution. So we first collect data from a source or sources, which is here the IoT devices. We ingest it, process it, store it, and then serve it and analyze it. And to ensure that all this happens in a synchronous way, we're going to need an orchestrator. So to be more specific, the solution we came up with uses the following. For the sources, we use a Python script to simulate multiple IoT devices. We then ingest the data using Kafka, process it using Spark, and then store it in InfluxDB. The serving analysis happens using Grafana, and the orchestration is done by Docker Compose. So to demo the architecture, we're gonna be using the commands on the left. So I'm gonna first ensure that all my containers are spinning and healthy. So I'm just gonna do my password. And as you can see, they're all running. Now I'm gonna be checking the logs to ensure that every container is doing its job. We're first gonna check our producer, which is the Python container. And as we can see, it is actively generating data and sending it. We now are gonna see if Kafka is receiving said data. So we're gonna use this command. And as we can see, the data is being consumed successfully by Kafka. That's it. And next we have Spark. So this command allows us to see the logs. And as we can see, it is sending data successfully right here. The number of rows sent is in this instance, for example, 4. And yeah, it is actively running and doing its job. Next, we of course need to check if InfluxDB is receiving the data and storing it. So we're gonna open a shell into the influx container and execute the following query. Well, we first need to make this smaller so that we can see the result. Well, now I'm gonna paste the command and that's it. You can see the data, it's stored, so everything's running as expected. We then move to Grafana, and to test that everything's working, this query, for example, runs as expected, and this data results from it. But the real intent of using Grafana is making dashboards that helps people make decisions or monitor stuff. This is an example of a dashboard that we come up with. The first row right here shows the number of devices that are sending data, which is here 5. This is just a proof of concept, so that's why. These are the last data received from the devices. And in the second row, we can see the sensor values over time, so it's technically the evolution of the data. And on the right here, we can see data about each device, about the state and stuff like that. And next, we can see the distribution of values received by these devices. And on the third row, which is the last one, we see the messages per minute. This row basically helps us identify if there are any issues with the devices that we're monitoring. So if the number of messages per minute becomes low, so we can deduce that some devices are down or something. Also, some devices, here is a table that if a device goes offline, it basically gets added right here. That should be all. So to conclude, I'll just go back here. We need to acknowledge that although this architecture is quite modern, scalable, and reliable, there is a bottleneck right here, which is Docker Compose. It's not really scalable, and in a real-life scenario, it would be preferable to use something like Kubernetes. So all of these containers would be spinning in pods, and Kubernetes scales them as it deems fit. That'd be all. Thank you for auditing.